Hello, today we will learn how to match equations with graphs. If you look at the equations, we have got six different equations. This is our equation 1, this is our equation 2, this is 3, 4, 5, 6. And we have got six graphs, 1, 2, 3, 4, 5, 6. What we're going to do is we will match these equations to the graphs. Okay, so I'll just erase what I did on the screen, and I'm gonna start. Okay, when I look at this first function or equation, the leading power that I'm seeing is x to the power 3, but there is also minus. That means the leading coefficient is -1, which tells me it is a decreasing function. So whenever you see the leading coefficient as minus, it can be -1, -2. You don't see 1 there because we don't write it. And the leading power is 3. So definitely this is a cubic graph. Okay, if I look here, the y-intercept is -2. Let's see if we can locate our cubic graphs in the graph. So I can see I've got two cubic graphs. This is one cubic graph. This is the other one. That means I should have two equations for cubic graphs. So this is the other equation. If you see the power is 3, that tells me it's a cubic equation. And the y-intercept for this one is -2 as well. So if you look here, so the y-intercept is right here. It's -2 and it's -2. But there is a clear difference between both. This one, the one on the left, this one is a decreasing function, and the one on the right is an increasing function because the leading coefficient is plus. Okay, so this if you don't see any sign, that means it's plus. Okay, so in order to find the correct graph for each equation, what we're going to do is always remember graphs, they originate in the left quadrant. So I'm going to just highlight it. So this is a left quadrant, this is a left quadrant, okay? And they extend towards the right quadrant. So this is a right quadrant and this is a right quadrant, okay? So I'm going to just erase this. And graphs always extend from the left quadrants to the right quadrants. So I will erase this. So you can have, okay, this is our quadrant 1, this is 2, this is 3, and this is 4. The left quadrant, quadrant 2 and quadrant 3, this is where the graphs originate, and they extend towards either towards quadrant 1 or quadrant 4. If the graph extends towards quadrant 1, then it's an increasing function. That means the leading coefficient should be plus. Okay, if we look at this one, so the graph originates in quadrant 2 and it extends towards quadrant 4. That means it's a decreasing function. Okay, the leading coefficient should be minus. So definitely it tells me for 4, this one is an increasing function. So we can safely say that this equation represents graph 4. Okay, and this one represents graph Roman numeral 6, okay, because it's a decreasing function. So I will just erase this, and I'm gonna get back to. So now we'll get to our other equations, and I'm going to take up the quadratic one. Whenever you see x squared, that means it's a quadratic. So this one is a quadratic as well because x to the power 2. For this one, the y-intercept is -2, and for this one the y-intercept is +1. So our quadratic equations are, this is our quadratic equation and this is our quadratic equation. Both graphs are opening upwards. both graphs are opening upwards. You know why? Because the leading coefficient right here, it's plus, it's not minus, so it's +1 on both. The y-intercept for the top one, this one is -2, so -2, the y-intercept is right here, and for this one it's +1, so right here. So we can clearly say the +1 is 5. So this one, well, I want to just erase it. So this one represents graph 5, Roman numeral, and this one is 2. The top one is 2. Okay, so what are we left with? We are left with straight lines. Straight lines are always, I'm going to just erase this, make it nice. Straight lines are always linear equations and always shown by, whenever you see the leading power as 1, so this one is a linear and this one is a linear function, okay, or equation. Because the power, if you don't see the power, that means it's just 1, but we don't mention it, we don't show it, okay. Now I can see the leading coefficient, it is -2, and this one is -1/2. That means both are decreasing functions. That means the graphs will originate in quadrant 2 and move towards quadrant 4. But now we have to find out which one is which. Okay. So for this one, I'm going to erase this so we can make it a little clearer. For this one, the y-intercept is -3. So -3, the y-intercept is -3. And for this one, the y-intercept is -3 as well. So now we don't know which one is what. So we'll find the slope. We'll find the slope for both graphs. The slope is given. We need to determine it on the graph. So I'll just erase this. The slope for this one is -2. That means for every 2 there is 1 rise. For every 2 rise there is 1 run. So the slope is -2, and let's see if we can find that. And this one looks more steeper slope. So I'm going to do, we'll see where there is a nice intersection of the graph and the grid intersection. And let me see if I can, this is another good point. I'm going to create a little triangle. I'll just count my rise. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So rise is 10. And we're going to do it minus because it's a negative slope. And run is 1, 2, 3, 4, 5. So if we simplify this, we can divide both by 5. So our slope will be -2 over 1, which is -2. Okay, so definitely this graph 1 is this one. Okay, and the remainder 1 is 3. So this is our graph 3. Okay, so this is how you can also find the slope of this graph the same way we did it for graph 1. Okay, so this is how we will we know what kind of graphs these are, and we can just match the equations with the graphs, and this is what it is. Thank you very much, and have a good day. Bye bye.